Okay, welcome to this episode. Actually, it is about how is the difference between SolidWorks CAM and CAMWorks. So I want to use SolidWorks CAM. Then we see is there any difference between SolidWorks CAM and CAMWorks. Okay, so how do you activate this one? Because now I've designed my part. It's a simple part I've designed. So I just want to demonstrate using SolidWorks CAM, because nowadays people are installing SolidWorks, and then are also using what you call SolidWorks CAM, because SolidWorks CAM comes with the SolidWorks from the version 2020, I think 2021 until today. So do you need SolidCAM to be installed? Do you need CAMWorks? Do you need MasterCAM? Or what is the advantage of using SolidWorks CAM? So let's go. We do a simple turning, then next we also do a simple milling. So come to add-ins on the settings. Once you have launched your software or you have a design, here where it is startup, it means that every time you start your software, all these add-ins will be starting up. That's why mine have put off so that the software starts up very fast. So in case I want to use them, I just click on this side. Like now here we have SolidWorks CAM 2023. I just click on this, then I click OK. Then I give it time to link on this, or to the attaches itself on this what we call feature manager design tree. This is a feature manager design tree. Once it attaches on this, and now I want to start the process. How do you program using SolidWorks CAM? So go to now, once it attaches itself on this, just click on. In case you don't see it, also you can go to tools, then SolidCAM. It is there, you can see it. But the shortcut, you can come to this what you call feature manager design tree. You click on SolidWorks CAM. Then first of all, you need to select your machine. That is the key part. So click on define your machine. Let it pop up. You have the 3-axis milling, 4-axis milling, and 5-axis milling, then single turret. Other machines like Milton, they can only be added here if you have installed your CAMWorks. That's the advantage of using CAMWorks, because now SolidWorks CAM doesn't have Milton. So in case you want to use Milton here, you can download, licensed, install and license your CAMWorks so that it can be used in SolidWorks. But for now, let's pick on this. You click select, then you select the machine. We are using our single turret metric. Then you click select your machine. Once you select your machine, all these are the details for your machine. You can click on the details to show you that the maximum fit rate is this. That is 15,000 millimeter per minute. And then the maximum speed is 5,000. So if your machine is less than that, I'll show you how to edit that one. Then next you go to tool clip. Tool clip, it allows you to edit your tool. For example, I have this tool, which is external turning tool. In case I want to edit this one, I click on edit. Then I can put the tool here. Maybe for example, DNMG. DNMG. Let's use 120408, for example. This is the hole I have, and then I can come to insert is diameter 15. Okay, sorry, the angle is 55 degree. Then inscribed circle is 12 because I'm using 12. Go to this, we check. Then the code remains this. Maybe I can put copy paste this. Go to this one. I want to use a chunk of 20 by 20. So my chunk is 20 by 20. When you edit, it's also populating on this side. Then my length is 125, so it is K. My holder is MDJNR 2020K12. 2020K12. That's the code of my holder. So maybe I can put here the holder. I can put the holder here for the purpose of seeing it. MDJNR 2020K12. M is multiple clamping points, so the insert has been clamped multiple times, 2 times. Then D, it is the shape of the insert. It is diamond. That's why it is diamond insert. So it is D. J, this is the reef angle, and also the clearance angle. R, the direction of cut. It is using. I'm using the right tool for cutting. Then 2020 is the holder size. K is the length of the tool itself, which is 125, as you see here. And then 12 is the size of the inscribed cycle of the insert. So this one you need to learn. You cannot just cram these codes. You need to learn. Then once you OK, you click OK. And then Here you can add other tools. You are allowed to add other tools because there are very few. I can click here, add other tools, and I can check which tool I want to add. All of them, they are here. Maybe I can add this one. I can pick that one. I add for boring. This is for external. This is for facing external. This is for thread cutting. This is for external. All of them. You see, once you pick on the tool, it populates itself. So you can add as more tools as you want, and then you can customize the tools here. You see, you have boring tools, drilling tools, flat enemy cutters, ball nose, hog nose. If you click on hog nose, it will show you the type of hog nose. All of them are here. If you have rimming tools, all of them will come. Flat end tappet, all of them, all the tools are here. But it is, if you have to define your own tool, you can come to user define tool. You put all your own parameters. Maybe, for example, I want to define my own tool. What is the designation? What is the shank? What is the tip length? All this, I can add my own tool. For example, the tool ID, designation. Let's use our assemble tool. You see, what is saying use the tool ID. It is almost up to 34. Then the insert type. Insert type, it is given the code. The insert ID, some insert summary. This is the tape rec angle. All of these, all the parameters. So you need to input all these features until you have your own user-defined tool. But for the case, you can also click on turn tool. It will show you all the turning tools which are available so that you can use them and edit for your purpose. Okay. So all this, once you click, you add a tool, you click here save. It will update the tool in the grip. Because we are using the tool clip. Tool clip is just a magazine. So our magazine is that. So the tool we have edited is this. That's the tool we have changed. You can go to post processors. Post processor is which kind of the machine are you using? If you're using maybe the controller Siemens 808, 828, 840, or numeric 1. If you're using HAS, maybe GSK 25i MC or TC, it depends on the controller. So you check on which controller. In case it is not here, you can also browse. It goes direct to where your machine is. You have the milling, you have turning. You click on turning, all these controllers will come here. In case you don't have this controller, the beauty with SolidWorks CAM is you're able to download all the post processor from online, then you install in your softwares. When you're using MasterCAM, you have to buy from resellers. But you're using SolidCAM, you want to buy the license, you're able to download it from using your ID from other sources that are selling the post process. You're able to download and then install. So because I want to use Siemens, I'm using Siemens 828. So this is turn Siemens 828. If you have also turned Siemens 840, I think in Kenya you have a few companies using Siemens 828 and 840. 840 are very few. Most of them are using 808 and 810. You see here, you don't have 840 and 808. So if you don't have 808, what do you do? That's the question. What do you do if you don't have 808? Siemens controller, you can use this or use this, or you can download from online post process and then it will work with this. So let me use Siemens 828. Then I say select. So I have picked my processor as Siemens for turning a Siemens 828. That is the post processor. Then the machine type is here. You can edit this one. You can put this. You can change. You can put a serial number or even expiration date for post process. No problem. In case it has APT, you can also use the APT file. That is automatic palette tool controller. You can put all those. But in case it doesn't have it, then you can go to posting. This one already, all these parameters are put here. Now the maximum RPM you can use, you can edit here. The maximum spindle X feet rate or Z feet rate, you can, the maximum distance it can move along Z and X, you can include here all these parameters. Then you can go to setup. All this setup, you can do user-defined code system, or you can leave with none, then you set your user-defined system from the machine. Then the chuck also you can do the same. You see, once you click on chuck, it pops there. But I don't want to do on this one. I'll show you how to do it. Then you click OK. So you have defined our machine. So that is how to define a machine using what we call SolidWorks CAM. Then next is the coordinate system. Coordinate system is the part origin. Where do you want to cut it? Somehow you can use what you call machine coordinate system, or you can use workpiece coordinate system. Machine coordinate system normally is all embedded in the chuck. But if you are using workpiece coordinate system, meaning you have to define where the tool 0 point is for the tool to remember, then where it will be starting cutting from. I want to use code to define my coordinate system here. The beauty here is you can use the SolidWorks model here. It has the user-defined, or you can use SolidWorks coordinate. The problem using SolidWorks coordinate is it will take this coordinate here, which are for Y, X, and Z. And because I'm using turning, I don't want to use SolidWorks coordinate system. I want to use my user-defined coordinate system. And because it has already defined for me that X is on the upper side, Z is pointing away. If I click on this Control 1, you're able to see my coordinate system. I can zoom this region. You're able to see my coordinate system. The Z-axis is pointing away, then the X-axis is pointing along this face, which is okay for me for turning. Okay, my tool is coming from up, down, left. So, okay, then I click just okay, no problem. Then next is my stock manager. Stock manager is the material which has not been cut. We call them blank or stock. So you have to define my stock because this is subtractive machining. If it is subtractive machining, I have to define my stock. As you see, this is the stock. The outer one is the stock. The inner one, this part is the target. So what is the material here? You can pick the material that you are using. This one requires somebody who has done engineering. You understand those codes for materials. In case you don't understand, you need to be trained on how to identify these materials. So if you are using D2, use that one, so you can define your materials from here without even defining from the design softwares. For example, if I'm using stainless steel 303, 304, 304L, or 316, I can define this material. But for this case, I can use any material. For example, let's say I'm using stainless steel. I want to define for this. Then these are strategies for the stock. So you using this, you can pick all this. Then I can say, is it hollow? If it is hollow, I put chord. If it is solid, I put solid. Then I go down here. I can define the offset here, or I can define the maximum diameter. So if I have a stock of 63.5, if I click on this 63.5, you see here it changes the offset on either sides, which means it is an offset of 13.5. Divided by 2, it is almost 6.75. If I go to this also, the inner one, I don't want to define the inner one, or I can come here, the outer one, I can say it is 6.5 symbol. Then you see what will happen here, it changes. If I say the outer is 13.5, you see what happens here, it changes. So it updates on either side. This is the block, the bar stock parameters, and this is the offset parameters. Then for maybe facing, I can put 2 mm. You see it updates here. Check how it updates. For clamping purposes, where the chuck would be, I can maybe put 20. You see how it updates itself. If I put 30 and then I click anywhere here, it updates itself. So which means this side up here is my chuck, where I'll put my chuck. Then this side where I'll do facing. Then the upper side where I'll do my turning. So this, the blank side you are saying, is the stock. So if I finish it, I click OK. Here also it has updated the parameters. In case you want to see to put it accurate, you just put 112 to prevent that those errors. So that because it has an error of 0.00001, which is very negligible when you're using what you call differential calculus. It's very negligible. 0.00001 is negligible. So you click OK. Yeah. And you have defined your machine. That's the first step. Second step is to define the code system. To define the code system, the next stage is to define the stock. Once you define the stock, you are set to go. This is automatic. I can proceed either to do what you call turning operations, grooving operations, or boring operations, or I can do what you call extract machinable features. This extract machinable features is very simple in SolidWorks CAM. So for you to do that one, just once you do a setup, click on extract machinable features. So it will detect all features that are required to be machined. Remember, it has to also check the tools that are required. That's why when you are define your machine, you need to pick the right tool grip and the right tool for each. So here, the software has selected that all these features are supposed to be done, which means it has face, rough turning, and finish turning. It has OD, outside diameter, rough turning, and finish turning, and it has cutoff operation. So do I need cutoff operation? If yes, I will remain it. For example, here, and then it has what you call recycle bin. That's the beauty of CAMWorks and the beauty of SolidWorks CAM. Once I delete this one, it will come to recycle bin. Let's see. If I click delete, say yes, it will go to recycle bin. So which means it does not disappear. But if I want to return it back, I just click here, then I click restore. It goes back to where it was. If you make an error, you delete a program or a feature, it will go to recycle bin. You can return it when you're using CAMWorks and when you're using what you call SolidWorks CAM. That is the beauty of these CAM packages. CAM is what you call computer aided manufacturing. These are software that help you to automate programming of G and M code. G is preparatory, M is miscellaneous function. We learn that one in our next episodes. So once you extract the features which need to be machined, next is, can you generate a plan? What is a plan? A plan means, let's go back. A plan means you want to differentiate between roughing and finishing. Here, it has put all operation as single. It has roughing, at the same time it has finishing. So if you want to maintain it, you can maintain. If you want to regenerate so that it rearranges rough operation itself with a different tool and finishing with a different tool, you click on generate operational plan. It's very fast. It's very fast. Once you do that one, you see here it has generated and it has picked the tool from the tool clip, which can be used. And you're able to click and edit. You can click here and edit definitions. So it is very fast. You can edit all operations. It doesn't mean that you see it has all the tools. You can change the tool, feed rate and spindle speed. You can edit all these rough features. You can edit all of them. How the NC program will be approaching and clearance, lead in, lead out, and other features that you want to check. So I want to use the operation. I have done my features. The software has identified the features which are supposed to be machined, and then it gave me an roughing operation and finishing operation. Now I went ahead to differentiate or separate roughing and finishing. If you see here, we have first roughing, first finishing, turn roughing, turn finishing, which was called OD. Then cutoff. Cutoff is just one operation. Then we can go to toolpath. We need to generate a toolpath. Toolpath is just a path which the tool needs to follow when it is cutting. Is it cutting linear using 0-1? Is it just approaching? Is it using 0-0? Is it cutting circular contour using 0-2, that is clockwise, or 0-3 and counterclockwise, or which code is it using for cutting? So when you click generate toolpath, it now regenerates the toolpath for each operations. If I click on this first operation, which is face rough, it shows you what it will be doing. If I go to face finish, it tells you what it will do. If I go to turn rough, it shows you the toolpaths. So those are toolpaths. If I go to turn finish, it shows you the toolpaths. So this is the operation the tool has. And then this is what is it has shown us here is what you call the chuck. So this, we are using a 3-jaw chuck. So it is holding our part. If you look at this, it is holding our part on this side. Yes. In case you see these jaws are so close to this, what you do is you go to stock manager, you click on this, you edit definitions, and then you check the length that you want to hold. Maybe here you put a length, maybe that is let's say 50, for example, 50, then you click OK. Once you click OK, it will tell you the parameters has changed. What you need to do is to update. So you click is update. You can come again, regenerate the toolpaths, say regenerate or update. It does the same. Then generate the toolpaths, yes. Then do assimilation. You see, now we have done this. If I click on this one operation, each one will show us its own toolpaths. You see, and even if I zoom now, you see where the chuck is. The chuck is very far away. Okay, if I click on here, stock manager, I'm able to edit my stock again. If I see the chuck maybe was again close, I can change here. I say maybe 40. I click OK. Each time you edit, it tells you the parameters are changed. What you need to do is to click yes to allow it to update. Then I can go to maybe the operation. I can say update. Okay, and then it comes to toolpaths, regenerate again. It updates all these operations. Then you see it orients the chuck where it's supposed to be oriented. away from the workpiece. And then once I do that one, I can generate these two operations where I can do assimilation. I can use what you call step through toolpath, which is 2D. It shows you the kind of operation they want to do, all of them. Maybe I can pick all of this, hold on control, select all of them, and then you can say step through toolpath. When I say step through toolpath, it shows me through the tool what it to be doing. I can reduce the speed here, even the position here. I can put the position. You see, I can track the position I show manually here to show where the tool is. You see, to show where the tool is. Now it is from 0. If I move away like this, it is going where the tool, it's like cutting now. Let me start from 0 here, then speed close to almost 50. Then I can click start. You see, this is what you call through step through toolpath when you're doing assimilation using SolidWorks CAM, which works the same as CAMWorks, which works the same as CAMWorks. Now let's do another simulation here for 3D. Click on this simulate toolpaths. Now this one gives us a 3D. The stock is the transparent one. Then the inner one is our target that we want to cut. Also, this is the speed. I can reduce the speed maybe for people to see it well. Then all these parameters allows you to change the view. If you want full view, here you click on this. If you want quarter view, I can click on quarter view. If I want, for example, half view, I can click on half view. If I want 3/4 views, all of these are the views you can change. A third of it, I can change the views how I want. Maybe let me use the half view, or I want to see how let's use a full view. Then I'll show you how these are the views. Then you can come here, you change the display. Do you want transparent? If I click on this one, I change the transparency of the views, the display. If I click shaded, it is shaded. If I click shaded with edges, it is shaded with edges. If I click translucent, it is translucent. Yes, let me use shaded, and then I'll change to translucent. Then here it shows you want to shoot a tool holder or not. All these features you can change. Once I'm okay, I click run. The tool will now start doing its operation. Now this is doing what you call facing. Yes, facing. That is finishing facing. Maybe I can increase the speed here. Example, it's coming to do rough turning. Yes, I've put it to slow motion. To slow motion. You can also pause here. You can click end the other side. So it is doing what you call rough turning. Rough turning. Does it collide with the jaws? No. Okay. So this is the safety point. It has left. Yes. Can I put it go fast? I think this one is hanging here. It is doing what's supposed to do. Okay. Because I've put less 50% for simulation. See now it's showing how it will be cutting. I've increased the speed, so let's see. Just for simulation, not for the real operation. And even it can also tell us the time it will take to do operation. And down here, the information. The current operation is turn rough. Then the tool is using is tool number 1 with the angle of 80. This one now, the problem of using automatic is it takes the tool that is close to it. But if I'm to select my tool, I can now click on edge operation, then I edit. I'll show you how to do that one. So this is the rough turning is doing. Then the last operation was, this is the finishing, sorry. Last operation should be, this is supposed to do finishing, you see, finishing. This is the finishing. Finishing. And then it will come and do parting off. The last operation was parting off, you see. Very accurate. That's what we call CNC part programming using CAM packages. Once it's okay, I can again select all of these operations, Then I can come here, simulate. I want to show you the next feature. Now I want to leave it transparent, okay? Transparent. And let me increase the speed, and then you will see here I've not started. Every time I start, it will be showing all the operation here. In case there is a collision here, you can also pick that select detect in any way there is a collision, then you stop. Then I can click. You see now it's updating here all what it's doing. This now I'm looking at transparent. Yes. The tool that it has picked cannot enter this region. So if I can also use a neutral tool, it's okay. See, this is very it is a very perfect. So I like using SolidWorks CAM. Okay, we have shown you how to do this one automatically. How do you edit? You click on any operation you want, right click, then you say edit definitions. Once you click edit definitions, any parameter will change, you will have to regenerate the toolpaths. So it will pop up, then here you can pick the tool you want. You remember here it took the tool that we didn't want. Maybe we can come and pick a new tool. A new tool. It's using CNMG. Maybe we want to use a new tool. Can you pick a new tool? Here, we can define our new tool here. You can define the tool, these parameters. You can define the parameters here. Come here. You can also define all the parameters you want. Maybe if you didn't want this one, you can put, for example, I want to put for example, DNMG 110408. If this is the tool I want to use, for example, that is 11, can come here, it is 55 degree, this here it is 11, yes, it is 11, I'm using 11, 404, 04, then I can change, copy this one, for example, I want to update this holder, I say it is 20 by 20 millimeter, and come here, say 20 millimeter, so I'm using K125 millimeter. I can update all these parameters. Use right tool. Maybe I can say it is MDJNR 2020K11. That's my holder. If this is what I want, I can say okay. It can update. They say change or add. You see, you can either add or change. So if you want to change to create a new tool, yes. If you want to add, yes. So maybe I want to add. I can say add a tool. It updates itself. You see, it updates itself. So it has added a tool. What I do next is I can come here the tool parts, because here I have changed the parameters. So I'm able to update. You see the tool, it has changed to 55, 55. The same for rough turning. I can change here, click here, right click, edit the tool. Edit the tool. Yes. I can edit the tool. Sorry, the operation. You click edit definitions. It will open up. It allows you to change it to update the tool. You see, all of these parameters are here. I can also update the tool. I'm using 55. Okay, maybe it is 11, for example. Here, it is DNMG. I want to put the holder. Here, I change to MDJNR 2020K11. This is how you weight the tool. I can put here this 20 millimeter. Here, this also, I'm using all these parameters. I'm feeding in the parameters, 125 millimeter. Then tool creep, let it be the way. I can click here. If I click OK, because I've changed that tool, click OK, it will ask me to update. Already, it has now picked. It has picked because that tool has the same parameter as the previous one that I changed on the face roughing. So this one will now update the tool automatically, and I can now click here, generate toolpath to update the current features. If I call on this, now you're able to see my turn rough, it has gone inside. You see, the previous one was leaving a huge material here because the tool angle could not enter inside. Now I have changed. If I click on now, do a simulation, for example, I'm able to see what the tool will be doing. I'm able to see what the tool will be doing. Let me run it. You see, the tool, I have changed the tool. Yes. The tool will now enter here because the angle has changed the angle. It will not leave too much material as previous one. You see, it has now entered inside, and then it leaves a small material for finishing purposes. You see, this is how you edit the tool. The operations or the parameters in SolidWorks CAM. And then next, for example, okay, let me again do a simulation. Maybe I can pick a single operation. Let me do again operation. Let me adjust this. You see, you can also adjust the tool, this like using the navigation panel. Control 1, Control 2, Control 3, Control 4, Control 5, shortcuts. So you can adjust all these parameters, yes, the way you want, or Control 7. Then you can change, you can configure all these operations the way you want, yes. Then you can try to move using the virtual bar, how you want this one to be, so that you can see it when you see it well when it's doing the operations. This is up to you to align the way you want. If I click that, this is the operation is doing along, is now along x-axis, because if you're using turning, the machine is single turret, normally it is XZ, that is G18 code. If you're using XY G7, if you're using Z G19, so you need to know the code for the plane selections. So the plane selection for my turning machine, which is single turret, is G18. Okay, let's finish this. Then next, we want to, this was taking time, no problem. Next is we want to generate a program. We want to generate a program for this. How do we generate a program? How do you post a program using SolidCAM? So you can pick all these operations if you want all of them, and then here you can either right click, you say post process, or there's a shortcut here called post process. So you can use either this one, post process, or post this. Or you can also change the simulation, the color for simulation. You can click simulation color, you can generate root parts. In case you have changed any parameters, you can do that. So you can click on this post process, then it will pop up. Where do you want to save it? Maybe, let me, for example, I want to save there. Because I'm using Siemens, the extension should be .mpf, main part program file. So I'm using .mpf because I'm using Siemens. If yours is different code, if it is ISO, you can pick other like .cnn or .ncz or .tap normally for works well with the router, CNC router, or .cam if you're using ProTrack machines. For mine is I'm using MPF, so I can use .mpf the way it is. Then you click save. You click save, then it will pop up. It will pop up here. So here I want to put the operations. What do I do? I can come to these operations. Let me go to I can use these operations, or I can even come here. It will show me all these are for the tools. Then this is for the operations. This is for setup. So it has 3 of them. So which one do you pick? The first one is for setup, this is for operations, and this is for the tools. So I want to generate the code for operations. So I click the second one. Then I can pick the one I want. You see, I want to select all of them. If you didn't want to select all of them, you pick what you want, like this, 3 of them only. But if you want all of the operations, you click up to this one. Then down here, you have this icon called play. If I click play, it now generates. I click play, it generates the program, you see, automatically. Then here, there's called an option here. Click this option, and then you can put a center line to differentiate each operation. And then here, click open the G code in this file so that you can open and see the program. Yes? Once I do that one, I click this. Just click this one. Then you wait the program to open the G code, so you to see on how you can edit the program. So let it open the program, then you can edit the program from there. Yes, if you have the code editor, now it has opened the program. Yes, let me zoom the program. I expand the program. You can see the program. This program, you don't need to edit more. As long as the parameters are correct, the current operation, you don't need to edit more. So here, you can change all this, you can remove. Anytime I remove, it gives me a different code. If you want to convert now, for example, you're using Siemens 808, and you want to convert your program to ISO mode, you put what you call G291. But if you don't want that one, you put the semicolon, and behind it, the machine will not read it, it will jump. The same as this, you see the first, this is the first operation, we call it header. The first operation, we call it header. This operation is the one that is telling us that we are starting the first operation, which is called phase roughing. G75, this is for the advanced machine. Normally it is using G75 code for what you call referencing. So it is referencing, moving to know that I'm using 75 to X0 and Z0. Then from there it starts cutting. If you see this one, the tool is now changing automatically. I'm using tool number 5, but the M is this. So you need to know that each tool you put here must coincide with the tool in the magazine. Tool magazine. Here I can change it. It's saying limiting spindle speed to 3000. If my machine goes to is maximum of 3000, I leave it. If it's 10,000, I can change here. You can be able to change. You can put, they say my machine is 3000. Let me put 3000. All these operations, maybe let me stop from this part. In the next episode, I explain the meaning of G code one by one so that you understand the meaning of G code. See, this is the G code we have generated from our program. Let me stop on this part. The next, I will show you what is the meaning of G code one by one.